pi over 2. Amplitude, that looks good. Period also looks good. Phase shift. Okay, so this could vary from class to class, but if you were asking me, I would want you to use pi over 2 and then say to the right. There's like a direction that's usually needed. And I'm not sure if that was, you can tell me now, was that covered in class? Like, do you say, give the value right, left of the phase shift?
Sorry, say that again.
Yeah, so just like what I'm trying to get at here is I'm trying to ask you, the way this is written is not like, I wouldn't think that would be okay. Normally it's pi over 2 right or left. Like you have to specify, pi over 2 right, pi over 2 left.
Yeah, I was a little confused on that because I saw the phase shift and then I also saw the vertical shift. So I was kind of like,
Okay,
I didn't really know.
So the phase shift is the part that's inside the parentheses. So the reason it's pi over 2 is this right here. Okay.
Mm-hmm.
And right, left depends on what's in front of it. This tells you whether it's right or left. All right. So the short of it is that if it's plus C, it's left. That means left C. If it's minus C, it's right C. But that's only if there's a 1 in front. So there's like a little more to do, which doesn't apply to this problem. But if you're not sure what I'm talking about, I can give you more clarity on that.
No, yeah, I understand that.
Okay. So now the vertical shift is, there's plus 0 here. So there is no vertical shift. It is 0.
Yes.
Okay. And just like when you were dealing with like quadratics, the vertical shift is always outside parentheses. So you can think of like this plus 0 as being that number outside the parentheses.
Right. Okay.
All right. Any questions on that before we move to 5?
No, I think we're good.
Okay. All right. So this has got an issue with the amplitude. You want to clarify that for us here, what the correct amplitude should be?
It should be 1/3.
Should be 1/3. Good. Period's good. Now the phase shift, kind of get my words here. It's pi over 4, but is it left or is it right? And it's based on this plus here. It's always kind of opposite what you might think. So
It's
this one
left.
exactly. Now this one does have a phase shift, and the phase shift's kind of in the wrong spot. That's the phase shift right there. I'm sorry, vertical shift. My words are so awful right now.
Okay.
They're completely wrong. The vertical shift is this number that's off to the left-hand side here. So, but here's the thing. It's kind of like the phase shift. You have to say 2 down or 2 up. You can't just say it's -2.
So how come on like number 4, the vertical shift wouldn't be 3?
In number 4, the amplitude is 3. The amplitude is 3, but all that does is it stretches it. Now, have you actually looked at any of these graphs, like in class? Did you guys graph any of these?
We didn't graph these particular ones because there's like graphing on the back, but I know how to plug into my calculator and stuff like that.
Yeah, and so like you would, like the vertical shift is literally like if the graph looks like this, it would everything moves up, so it would, that it would be the same graph but up or down. The amplitude stretches it, and I mean we can do a whole lesson on this, but it sounds like you've already kind of gotten to the middle of it.
Right.
So good question. The vertical shift is always the number outside here. The amplitude stretches it. Again, it's really analogous to like ax minus h squared plus k. The a is like the amplitude. The phase shift is like h. That's the left or right. The k is the vertical shift.
Yeah.
It's really similar to that. All right, so let me know when we can move on to number 6.
Yes, number 6.
All right, amplitude looks good. Period looks good. We want to say now pi left.
Okay, yeah.
What is the vertical?
The vertical will be 4.
4 up, down,
Up.
up. Good. 4 up. Good. All right, so we'll skip 7 through 10 for now and come back to them if we have time. But the back here, like, what do you want me to do in the back? Check these. Do you?
Let me see the back. Maybe, I'm trying to remember if there was any of them that I was like confused on. Actually, maybe if you could graph number 11. I don't know if that doesn't really look right to me. That might be right.
There's an issue with 11 in 12 and then it's all the vertical shift. Like the issue is almost all completely with the vertical shift. 14 might be okay. So I guess we'll start from the beginning here on 11. I'm sorry, it's just doesn't like there if you miss one thing, the graphs are just completely wrong.
Yeah, right.
All right, so the amplitude here is not 2, it is 1.
Oh, I see.
The period is 2 pi over 4, which is pi over 2. That's fine. The vertical shift is 2 down. So there are a couple ways to graph this. The way that I show it is that you start with the phase shift and period, basically. So this one does not have a phase shift, but it does have a period adjustment. So normally, and do you have to go both left and right on your graphs?
Yes.
Ah, darn, that's always a little more difficult here. Okay.
Yeah.
So you go out one period. So in this case, you go out pi over 2. And I'm sort of arbitrarily choosing where that is, but you go out pi over 2 and then you cut it in half, pi over 4. And then you need to cut both of those in half. So this is where it gets a little tedious for students are like, it doesn't look like you've labeled those. I mean, you can, I guess, so it looks like I'm sorry, that you have. So pi over 8, 3 pi over 8. We can talk about how to do these faster if you want. But then you draw basically, well, what does a sine look like? Well, it starts low, goes up, comes down, and goes back up. So your first kind of graph looks like that. And that's only taking into account the phase shift and the period. Is that okay how I've done that?
Yes.
So this would be 1 and this would be -1. I'm intentionally like not using the correct grid areas because I want you to not get caught up in that. Now you unfortunately have to go both positive and negative. There is symmetry, at least when it starts at 0. So it's minus, minus pi over 8, minus pi over 4, minus 3 pi over 8, minus pi over 2. And there is symmetry. So it goes down, comes back up. Now, when you're graphing these, you kind of want to be good about getting smoothness. I'm not trying to be critical of your drawings, but they need to have a nice smoothness to them. Try to avoid drawing straight lines.
Right.
And you've done the better thing than me. You've actually put the arrows at the end. I'm awful at that. Okay, but again, this is just the phase shift and the period. Okay. You would next address the amplitude, meaning like if it amplitude and reflections, which this one doesn't have any.
Mhm.
So it's the same graph, but what you're maybe seeing here is that you don't try to do it all at once. You try to do it in pieces. The third thing you do is always the vertical shift. Okay, so the vertical shift here is down 2, which means every single point goes down 2. So let me label this correctly. So every single point here, I'll do this in red, goes down 2. That goes down 2. This one goes down 2. That goes down 2, down 2. And it looks the same. It's just that it's down 2. Every single point, though, comes down 2. And
Okay.
notice I'm drawing the points before I try to connect them. Could also help here. This one is down 2. You have to graph it in this order. Like, even if you try to graph it all at once, you still have to do it in this order.
Right.
And this is where I've done the most students. We do an entire lesson on just we do an entire lesson on just graphing because this is so difficult.
Yeah.
And you could, it's reasonable to ask the question like, well, why would I ever need to do this? And it's like, well, you really don't. You would go to a graphing tool and you put in your calculator. Are you allowed to use your calculator to graph these?
He hasn't like taught us how to. I know how to graph them, but we've usually just been doing on paper. I don't think he hasn't said we're not allowed to, but
I'd recommend just asking, just because you'll know going to the test, because if you're allowed to use your calculator, I can show you how to graph these in the calculator, get the nice looking graphs, and we could actually sort of do it in pieces so you could see it. But if you're not allowed to use your calculator, we have to do it by hand this way.
yeah.
So if you're ready here, we can do the next one, number 12.
Yes.
All right, so amplitude, you want to adjust that here again. What is the correct amplitude on this one?
It is 1.
Just 1. Period is 2 pi. That's good. This one does have a phase shift. PS is phase shift. It's pi, but is it left or right?
It's gonna be right.
Yes. If you ever need like, well, how do I know? Like, think about like something like x minus 2 squared. That's 2 to the right, or x minus 3, so on. This one has a vertical shift, which is 3 up.
Okay.
All right, so these are the absolute most difficult to do when they've got both a phase shift and a period. In this case, the period's 2 pi, but whenever you have a phase shift, those are always just horrible. So normally you would, with cosine, you would just go out to 2 pi. Okay, because that's the period. Cosine starts high, comes down, goes back up. But the period, you have to push everything out pi to the right. Okay, so you have to extend this out plus a pi, basically. So it's 2 pi plus pi, which we'll call 3 pi. Okay, and then I'm putting a pi here because that's the phase shift. So when you graph these things, you actually really start at the phase shift, and then you add a full period like this. Then you need the midpoint. Then you need the one in between the two, and then the one in between the other two, like that.
Okay.
So normally cosine, starts here at the origin, but it's up. It starts high, goes low, comes back up. This one's shifted out. So you pretend like this is your new y-axis, your origin, and you just graph it this way. So you're like, okay, it starts, goes down, comes back up, like that. And so this takes into account the shift to the right.
Okay.
Any questions on that?
No.
All right, so now we got to go left, and normally there's symmetry. So like normally it would be like, okay, you go positive pi, but then negative pi, but you have to like almost treat this new place here like it's a new axis. So you're going like this is, I don't want to say this. This is always so awkward to explain. You're going left 2 pi. So it's as if though, how do I say it? Like that's 0. That's, I haven't done the scaling on this very well. So that would be pi. I really have not done a good job scaling this. Is it okay if I move this line here, or is that going to be really kind of upsetting?
Oh, no, that's fine.
Okay. All right, this will look better now. So you can think of this as pi over 2, 0, negative pi over 2, and then negative pi. And you're just going backwards. You're like, okay, got to come down, hit that, come back up, like that. So that takes care of the period and the phase shift. The next little piece is the amplitude and reflection, if it has any. Like a reflection would be if it was negative, like 3 minus cosine. This one doesn't have that, so there's no amplitude change. It's just 1, so no changes there needed. We do have to deal with this up 3. So that means every single point is moved up 3. And so I've not done a good job of leaving room for this, but I think I can grab all this and shift it all down. Yeah. So we're gonna graph this one. Darn it. We'll do this in red here. So every point goes up 3. 1, 2, 3, and 1, 2, 3. But it has the same shape. Like that doesn't change. It looks exactly the same. It's just moved up 3, like that.
Okay.
All right, so graphing secant and cosecant, tangent and cotangent. So cosecant and secant are very much related to what we just did, but they're different. Like it's there's a starting point like we've been doing, but there's a bit more to do. Is it okay? Do you want more sines and cosine graphs, or do you want us to just move on to like 13, 14?
Let me see if there was any of the other ones on the page that I like actually need to go over. No, we can just move on.
Okay. All right, so 13 here, it's a little bit odd to think of a amplitude for the final graph of a cosecant or secant, but it is necessary. So this one again, the amplitude is going to be the 1, just the 1, and there's a vertical shift of 4.
Oh.
Up 4. Is that clear why that is?
Yes.
Okay, great. Now, next thing here is, well, like, what do you even do? So, in class somewhere, the teacher should have said, when you graph a cosecant is really 1 over sine x, and you actually graph the sine x in this case. Is that okay?
Yeah.
So you're like, what do you mean? Like, you got to graph a sine and then deal with this 4 later on. So we're going to go to a graph here, and we're going to graph a sine. So we'll go out 2 pi, pi over 2, 3 pi over 2. So sine looks like this. Now you're supposed to do it in a dashed line because it's not the actual graph, but that is it's kind of up to you. Then you go the other direction here, minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi, and then you just go the other direction. Okay. So you come down, come back up like that. Okay.
Okay.
So that's the first part. Next thing is to identify the vertical asymptotes. Okay, because you are not allowed to divide by 0. Sine cannot be 0. So where is sine equal to 0? Well, wherever it crosses the x-axis. So these are vertical asymptotes. And I can see that you've done that on your graph there. Like that.
Okay.
Okay. So normally, and we'll put this in next here, and I'll do this in different color. Normally, this is sufficient. So you would say, okay, I'm going to put that there. I go down here, so it touches at these sort of tangential points. And your teacher usually wants to see 2 full periods, meaning a top and bottom, okay? This is just the cosecant part, by the way. We haven't dealt with the 4 yet. Is it clear? I mean, is there enough like background from class to know why it's this in blue?
Yes.
Okay, now the last part is to go up 4.
Right.
So each of these points is going to move up 4, okay? Which means like the one that's maybe the most awkward one is this one down here at -1. It's actually up here at 3. 1, 2, 3, but it still comes down. And this one that was at 1, it goes up 1, 2, 3, 4, and it looks like this. So there's still this like top and bottom. This one right here moves up 1, 2, 3. Oh boy, did I not count correctly? Oh, that's really bad. Really bad. Sorry about that.
No, you're good.
Gosh. Okay, so right here comes down, 1, 2, 3. This one comes down. So the vertical shift comes last. This right here is up. This one over here is up 1, 2, 3. So it's going to look like this other one, like that. This is a place to ask your teacher for some guidance here. It's like, what do I need to label? Like, do I need to label the asymptotes? Do I need to label the points at the top and the bottom, the peaks and the valleys? I mean, these are all things I would expect, but it's really up to them to decide, what they want from you.
Right. Okay, that makes sense.
Okay, so we can move on to 14, maybe?
Yes.
And I guess you'll see this again in, pre-calc trig. So, you don't have to, we don't have to go crazy here, but there is a lot that goes into this that maybe I'm not giving enough information on. Amplitude here is correct. Period is correct. This one, though, does have a phase shift. What would that be?
The phase shift would be left pi over 4.
Yes, pi over 4 left. Very good. Okay. And this is it's really like 1 over the cosine x minus pi over 4. So we're going to graph, we actually have to graph cosine x minus pi over 4. So that's like the thing here. So normally you'd go out 2 pi for your period and it starts at 0, but because it's pi over 4 left, you have to start left pi over 4 And then you have to go out one full period. So you have to basically add 2 pi to this, which is a little bit awkward. Becomes 7 pi over 4. So it's somewhere off to the side here. It's like minus pi over 4 plus 2 pi. Make a common denominator. Like that. So then kind of like without normally cosine starts it starts high. I don't know how many of these midpoints you need. You probably need at least one here. This is at minus pi over 4 plus 7 pi over 4, which is 6 pi over 4, but then you got to cut it in half. Ends up being 3 pi over 4. And then this is 5 pi over 4 and 1 pi over 4. So you need some of these points here because you've got to always graph 5 points. So this one comes down, down, up, then up, like that. So it's a lot of effort sometimes to find these in between values.
Right.
Now going left's a little bit easier because you're negating 2 pi, or you're like adding negative 2 pi. So it's like minus pi over 4 minus 2 pi. That ends up being minus 9 pi over 4.
Okay.
So this is minus 5 pi over 4. And then you find the midpoint between them. So what I'm looking at here is the numbers, like minus 1 to minus 5 means I'm going down 4, down 4. The midway between them is minus 3 pi over 4. And then the midway between this one is minus 7 pi over 4. And then you've got to go, you start coming down. You come down, hit the bottom, come back up. So we would be done if we were graphing cosine x minus pi over 4, but we're not. We're graphing the secant of x minus pi over 4. So just like in the previous problem, wherever it hits the x-axis, you have to draw a vertical asymptote.
Right.
I know this graph is really crowded. I don't particularly like it, but you got to put some sort of vertical asymptote in there. They're grading for where it is, not necessarily like how accurate it is to scale. And then in each of those regions, you got to say, okay, it's that one. It's got a touches. And then you got kind of a problem over here. Like this keeps going. So you really, really, really probably want to give the next place that this comes down. But that's kind of up to you and your instructors, because there's really one at 9 pi over 4, and that's where this ends on the right. Same thing on the left here. It's like it really does come down and hits at minus 11 pi over 4. And they usually want to see two full periods. So I've kind of done 2.5. You can think of like top and bottom as a period, top and bottom as a period, but you need to close out, either the other top or the other bottom.
Yeah, I get that.
Okay. All right, so 15 and 16 are cotangent problems and tangent problems. These are similar. They're not quite the same. Amplitude looks good. Amplitude looks good. That looks good. Pi. Okay, so small period issue with both of them. Actually, only the first one. I think we'll just have to make some small adjustments to your graph. So let me grab this here. All right. So for sine, cosine, secant, and cosecant, the period is always 2 pi over b. Okay, but for tangent and cotangent, the period is pi over b.
Right.
In
I
your
always have to think about that.
yeah.
I've caught myself like messing up.
Now, why is that? I don't know why this it is just is. I mean, I don't really dissect it that much, but it's a small little thing, and it affects all your graphs. So the period, your b value in this problem is 1/2, so it should be pi over 1/2, which makes the period 2 pi.
Right.
Okay. Now, it's really important to have like a baseline of what tangent and cotangent look like. And this we really probably should just start over here. So if you're okay with that, I'll do that over here off to the right. So you're actually, I take that back. Sorry, this is cotangent, isn't it? This one looks okay. So the issue with this graph is just the vertical asymptotes. This should be at 2 pi, and this would be at pi, because it's always right in the middle. And then just like to see that a little bit, snake a little better. So you normally go out one period for your vertical asymptotes, and then you go left. So this would be minus 2 pi. This is minus pi. But this looks okay. I mean, this looks good from here.
Okay.
All right, we can move on to the other one here. Tangent. So this one you did do correctly. Yeah, this one looks really good. Yeah, I mean, I don't see any problems with this one actually. Sometimes teachers want you to label the points on the tangent and cotangent. So you might ask like how many points you'll be expected to label.
Yeah.
Sometimes they just want that. I'd like to see one more over here. I'd like to see that this is at 3. This one's at, minus 3.
Right.
But overall, pretty good. Okay, do you want us to go back and look at 7 through 10? Do you want us to do some more of any of the ones like this on here? What would be best for you?
Maybe look at 7 through 10.
Okay. All right, so 7 says like you must make this a sine graph, which is really helpful. Like if you had to choose between sine and cosine, it could really be challenging. So this is just a working backwards problem. You're not even having to do that much here in terms of like it's a sine bx. So you need to know the period to find b, big B, and you need the amplitude / if there's a reflection to find big A. So let's start with the period. The period is you either look at it as peak to peak. So for example, from this red point to that red point. You can also look at it as valley to valley. Excuse me, I was back here. Valley to valley. Okay. And you want the linear distance. So you really want like this horizontal distance here, straight line, linear distance. and you're doing a calculation, you're going right minus left. And if you're not sure what I mean by that, it's like pi minus 3 pi gives you 4 pi. And that is the period. Okay, but the period is not b. The period is 2 pi divided by b.
Yeah.
So you might have seen this in your book, b becomes the 2 pi over the period. Your period is 4 pi, 2 pi over b, which means that b is 2 pi over 4 pi, which is 1/2. So we got part of it here. B is 1/2. And you get that from the period.
Okay.
All right, now to find a, so the amplitude is the distance from this what's called the center line. You think of this as the center line up to the top or down to the bottom. That's the amplitude. It's not necessarily the a value. The a value includes whether there's a reflection or not. This one does not have a reflection, but it's something to think about and to look at. So this one, the amplitude is 2, the a value is 2, but it could be plus or minus 2. So you have to decide, okay, is this actually correct? Does sine actually go up and come back down? It does. So kind of a long-winded way of saying that this is kind of the standard form, 2 sine 1/2 x, like that.
Right.
Any questions on that before we move to 8?
No. Well, actually, oh, okay. I'm just trying to like look at it again. So 2, how did you get the 2 in front of sine? Because it's just on the
The a is 2. Yeah, the a is 2, but it's like, is it 2 or -2? So if this graph went down, you can imagine it going down and coming back up, then it would be -2.
Okay, yeah.
All right, so let's look at another problem here. All right, so what I'd like you to try to do in this one is tell me the period. Start with just the period. So basically, peak to peak, valley to valley, if you could give me just the period value. Or if you're not sure, ask some questions here.
So the period, it's pi.
It is pi. So another way to do it, this one's a little bit harder, is like you pick a point and you got to come back to that point. That is the period. So to find b, period is 2 pi over b. Could you solve this for b for us, please?
So
Any questions on that, or?
so then b would be just pi. Yeah.
So b, like you can cross multiply here. You can remember that b is really 2 pi over p, like it switches positions, but you have to get you have to cancel the pi's. You have to divide both sides by pi at some point. So b is actually 2.
Okay.
Now, how about the a? Is it? Well, I'll let you calculate that. Go ahead and try to determine the value of a for us, please.
So a would be 4.
Yes. So this is 4 sine 2x. All right, any questions on that?
No.
Okay. Try the next couple. These are more similar to the last two. The teacher really hasn't done anything odd here. It does seem like you're getting kind of the softened version of what you'll see in trigonometry here.
Right.
So just like in the previous problems, you got to find the period and the value of A. So period leads to B. The period here is pi over 4. And period P equals 2 pi over B. If you solve this, maybe that's what's been overlooked. If I take P and multiply it by B and 2 pi times 1, and you divide by P, B equals 2 pi over the period. So sometimes students get comfortable and they're like, okay, I'm just going to go right to that step there. So that's 2 pi over 4. You have to multiply by the reciprocal.
Right.
So in the numerator there, you get a lot of cancellations here. You end up getting 8 for your B value.
Mm-hmm.
All right, what about A? What do you think A is in this problem?
A would be -3.
So you say that it's negative. So remember, this is a cosine now. And actually, I didn't even say that. That's probably why. Cosine starts high, goes low, and comes back. A negative cosine, I'll draw that in red here, would look like this. This is a negative cosine.
Oh, so it is.
It ends up, this one's
Positive?
positive. Yeah. So 3 cosine 8x.
Okay.
All right, so we don't have much time here, but take a minute or two, see if you can find period and amplitude on this one, and then convert those to big A and big B if you can.
So the period is 8 pi.
Okay, so what is the B value then? What is the B value?
So it'd be 1/4 pi.
Just 1/4. The pi's cancel.
Oh, right. They cancel.
Okay, and then A
Is
is
1.
it'd be 1 if it went up to the 1. It's actually only going up half.
Oh, 1/2. 1/2.
Yes, A is 1/2. Very good.
And it's cosine.
It is cosine, so it's 1/2 cosine 1/4 x.
Right.
Right, so go ahead and get that down here.